So good morning, everybody, and thank you for inviting me for this presentation. So yes, to present myself, I'm Alain GUESQUIERE from IRD, Montpellier, and my field of research is more in genetics, genomics, but I think that this exercise is quite interesting, even for me, I'm not a specialist in agronomy and rice cropping system. Just to come back of of the subject today, I like this slide because it clearly represents that the major rice production are concentrated in different so-called mega delta, and which are very, very concerned by climatic change effect and the rise of the sea level. So as a matter of fact, rice is probably one of the crops which are very, very stressed by climatic change. So I can remind some important points and facts about that. Okay, so another very important point is that there is also very good superposition between rice production and the poor people, as you can see. And again, still nowadays, majority of the rice production is produced by very poor people, particularly in Asia, but also in Africa. Another, okay, another very also important point is the growth of the populations, and probably this majority of very small farmer, very small landholder will continue to contribute to approximately 40 to 50% of the rice productions, and mostly in Asia and also in Africa. Very important to keep in mind. Another interesting, we are coming now from our subject, is that during the high yielding variety and the green revolution period, the rice yield was greater than the expand of the population size. But at that time, yes, the genetic gain was important, but now genetic gain is stagnant. There is a stagnant system, and it is also a reason why that genetic improvement and breeding can find some breakthrough to allow for new innovations. There is also the context of increasing rice price, even if rice is not completely concerned like international market and speculation like maize and wheat. There is this continuous tendency which can create, like in 2008, some instability and problem mainly in Africa. Also, yes, we know, and also the student presented that we are in a context of increasing resource scarcity, land, and with the development of city, very big city in Asia, in China, the labor also, the human resources are attracted now to the city. So it's a very important critical problem, and also in Africa, and also the water scarcity. You have now, because of the climatic change, increased stress environment. So the students talk about the salinity, and as a matter of fact, was a very important problem. Is you have heat and high temperature, we can provoke sterility, the flood time, the flooding in the delta are greatly concerned by that adverse systems, salinity, droughts, many stress. you have also an important point, I insist on that, that the rice cropping also a very negative impact because of the pollution of the, of the ponds and by overuse of nitrogen in algae development. You have also a recent problem with the accumulation of heavy metals, yes, in the rice field, too much close to industrial activities and factory, and because rice can accumulate, and so the quality of rice is endangered. And also you have this problem of greenhouse gas emissions, approximately, depending on the year, but a very important proportion of the methane emission in Asia is due to the rice cultivation. And it impacts greatly on the climatic, on the effect on climatic change. And also as rice was very intensified, the pesticide used induced several outbreaks of insect and adverse problem, because this insect and plant are vector of other rice disease. So facing to that, what can we do? So I took a very basic definition of adaptation, and depending on my background, this is, you probably know, this triangular model between genotype, phenotype, environment, and environment including also management conditions. And finally, the adaptation is the cost, the distance between a given phenotype and the optimum phenotypes, which can minimize the reproductive effort, the nutrient use, the distribution of the resources, etc. So what we can do, the first is to rely on the plant improvement, which is based basically on genetic diversity, natural genetic diversity, and also the control of environmental conditions, the resource management, cropping system. Already the student explained very well what we can do in the context of the Mekong Delta River. I didn't talk very much about the post-harvested, but it's also a very important component to ensure the quality, the safety of food. And it's now in the context of not system, but sustainable development goal, very important component to develop the food security. So two major points, the genetic and diversity and the use of genetic diversity for plant improvement, and some aspect on the environmental conditions. So I will take some example from Africa, because I know best this context in Africa. So rapidly, the rice genetic diversity, very fortunately, the Asian genetic rice species, Oryza sativa, has a very large genetic diversity, so very useful for the breeding, with two main family of varieties, which have been derived from two different domestications. And traditionally, we have the Indica varieties, more adapted to South Asia and inundated condition, and Japonica family of varieties represented in Japan, north of China, etc. And you have very large, diverse agroecotype adapted to traditional systems. So you have, for example, the rain-fed lowland rice. That means the rice developed very traditionally, still nowadays in Africa, where you have some water and also very small nursery, because rice still now is transported. The area very close where rice has been transported, and all this work is handmade very important also to keep in mind. You have the upland rice, usually in the slopes of the forest area with slash and burn system, traditional practices. And another picture in Madagascar, where probably it's the best system of irrigated rice with control of water supply. Those are the main cropping system in Africa. And you have also additional system in mangrove area and so on. Because I took example coming from Africa. So I mentioned also an African rice species, because at IRD we did a lot to work on it, but it is still disappearing rapidly because it has many drawbacks, but lodging susceptibility, low productivity, but it has interesting genes. For example, the early flowering a bit to escape heat temperature. The African rice has this characteristic. It has also resistance to nematodes, to viruses, and at IRD and in cooperation, we transferring several genes from Glaberrima to Zacetiva, even if there is also strong repetitive bias. But now it's in economical importance is very small, and all the Glaberrima variety have been replaced by Asian rice variety. So, sorry. Yes, this genetic diversity is very important. So I just mentioned that rice from the 20 years is considered as a very good model for genetics, for breeding. It was the first plant which was completely sequenced. Many tools, many biological resources have been developed for genetics, but also for breeding. And the last important project is the 3,000 genome, where 3,000 varieties have been completely sequenced, and it's very useful to continue increase the knowledge on the organization and genetic diversity. For example, you have in red the Indica family of variety, and in blue, dark blue, the Japonica variety. You can identify many intermediate genotype. If you zoom on the blue Japonica, you can also separate in 3 other groups with the temperate geographical groups and 2 tropical groups, and so on. And this activity are very important to continuously elucidate the organization of the genetic diversity. Here, I try to summarize rapidly some important steps. So the student mentioned the first step will be conventional breeding and the green revolution period. It was an important step for breeding because it has reduced the durations to better fit with the climatic or rice cropping conditions, and the development of semi-dwarf varieties and high returns to fertilizer. It was this effort combined with also some important effect of mechanization, use the fertilization, which can go to more than maximum 10 to 11 ton hectare rice. The second important period was the 1890 period with the development of marker, the genetic mapping. We're using RFP marker, microsatellite, SNPs marker now, and it was very interesting to identify quantitative trait loci. That means loci which can contribute to explain an important part of the phenotypic variations, so, and measure genes have been characterized in the genetic diversity. So the student mentioned that because we have, for example, the sub1 genes, which is a genes which allow a good adaptation during the flash flooding which can appear, because even if rice is adapted to the inundated condition, some varieties cannot accept too long period of submergence. You have saltol QTL, we can provide better tolerance to salt intrusion at the beginning of the vegetations. An example of, for example, of the drought and root system architecture analysis. There is very large diversity. On the left, you have the indica root system, very small and with very thin roots, compare on the right to the upland rice variety, which has very natural long roots adapted to upland conditions. And this diversity of phenotypes in roots enabling to determine the QTL, which were analyzed in different genetic background or in different evaluation condition and some meta-analysis could reduce the interval, the confidence interval to increase the efficiency of marker-assisted selections. Marker-assisted selection was very important to gather, to increase interested genes in elite materials. An example of that taking in the irrigated rice in Senegal, where also, like in Mekong Valley, there is also some intrusion of salted water in the dry season, where they have developed systematic phenotyping platform at the early stage. They are doing artificial salinized field to screen either natural accession or progeny for genetic purpose. And you have here an example where they are transferred the saltol QTL on the right in soil 108, which was an adapted variety to irrigated conditions in the soil, which have a good habit in in salted conditions. Now, another is I summarize rapidly other steps. Since the last 20 years, the marker assisted selection process was completely organized with a very high throughput system for the identification of donor, because the interested traits are very scattered in the genetic resources. High throughput platform for genotyping. You have also development of methods of simulation for optimize the breeding schemes, and also very important the characterization of key environment. Very important point. And more recently, with the decrease of the sequencing cost, the marker-assisted selection process was extended to the complete genome with thousands and thousands of markers. It's very useful to gain a small proportion of genetic gains, and particularly if some traits are, depending on many QTLs and small effects. Also, I mentioned that rice benefit only from the tool of biotechnology, genetic transformation, but genetic modified rice regulated in developing countries, not grown. More recently, you have this very interesting new technology, genome editing, which can develop site-directed mutagenesis to modify a single genes by creating small deletion. So I will not insist, but it will be much more precise and much more clear to identify or to create new variability. For example, it's very interesting to focus on susceptibility genes, which can be transformed in resistant genes in rice. Okay, so briefly mentioned that. So now moving to the other driver, other component, which is the agronomy, the land management. So I insist on the fact that to complete the student talk, that the impact of laser leveling in irrigating condition was a very important point, or more focus in developed country, because if the Mekong Delta is flat, in many other countries, it's very important to optimize this land level because of the weeds. Because the weeds is a very important problem in rice, the mechanization also, and so on. Because in Africa, in the table, still nowadays there is a very, very important gap between the actual yield and the actual potential and the yeast potential. Yes, first explanation is that in Africa, the soil are very poor with phosphorus, nitrogen deficiency. You have also, in some cases, toxicity of soils. And also, most often, all the component of the intensification are not appropriately combined. This is an important different picture than in Asia, for example. Here, another example from the river valley in Senegal, where similarly to the Mekong Valley, it was possible to finally to optimize based on the adoption of new method of rice cropping system, which is for example, the direct seeding and also mechanization to adapt rice for second crops, because in Senegal and on many other places, we have two bad periods. The first during the dry season with extreme high temperature during the day, which provokes sterility if the plants are flowering at that times. And also at the end of the years, in December, January, we have also a cold period with delayed development, and also we can provoke sterility if the variety are flowering at that period. And finally, this is the joint effort of the mechanization, direct seeding, and so on to save time in the cropping calendar, and the development of medium duration and short duration genotypes with cold tolerance, and in some cases also with resistance to salinity, which give two other rooms for second crops, and in the same time to escape adverse condition. I can give other point concerning the aerobic rice. The student presently presented that. I think it's a very interesting very option as a climate smart rice cropping system. So in this system, you are no continuous inundations, but in fact you have two types of aerobic rice: the saturated soil cultures, yes, to maintain level at its optimum, but you need absolutely to get a land laser leveling. And this alternate system where you wet and you dry the rice field by intermittent irrigation, and probably it's adapted, more friendly system for developing country, and its interest it prevent the water losses, and is also a system for mitigation of greenhouse gas emissions. But yes, we can discuss on it with the student, because my formation of that is that typically it's a system where we need a trade-off between the productivity, the economical proposals, ecosystem service, and yield, because in fact there are some penalties. If, for example, in Asia you are at a maximum of the yield capability, probably the adoption of this system will decrease the yield. But in Africa, with this gap between the actual yield and the potential yield, probably you can increase the yield and finally comply with the agronomical component, and also with the economical component. So this is why probably this new system, because agriculture is not yet developed in Africa, not yet, but it is a promising way. My last slide is to ask this question: if Africa can be the potential granary of the world, because as you know, there is no possibility at present to increase the land in Asia. On the contrary, there is a diminution of the land for rice because of the development of cities, because of the erosion, and probably Africa has this potential, because until now there is very large irrigated area which are not completely optimized, developed, and also we have more than 100 million hectares we are completely not used for agriculture. So probably there is very important potential, but in Africa it is the major problem is the labor productivity and the adoption of mechanizations. Another important point is the seed system production. Very difficult to obtain good seeds for rice, and an important, very different context, different from Asia, is the lack of attractiveness of the rice economy sector, and usually the imported rice is much more cheaper than the local rice produced in some African country. So it needs to develop greatly the rice value chain, the income of small farmers, and it is depending on the development of incentive policy and the agribusiness development. So I hope, so I suppose that I finished, yes. So many of these, and the example that I have given are coming from this partnership, research partnership we have developed during the last 10 years with IRD, my institution, with CIRAD too in Montpellier, in very close collaboration. We have 3 international centers represented at IRI. I see that you took example from IRI, Africa Rice, or in Côte d'Ivoire, Senegal, Madagascar, and also in South America, ICIAT and Japan, JIRCAS, the Japan Research Centers. And this is a consortium to develop many research on rice in all the different thematic areas. So I'm finished.